Hey, welcome back everybody. Hopefully you had a great Memorial Day weekend. Serious. The weather was beautiful and now we're in June and we got 3 weeks of school left. New material. We're going to have dice. We're going to play some Yahtzee. We're going to play some cards. All about probability. Okay? So the first few minutes of class we've got to get organized. Alright? So you don't have to throw anything away, but we want you to make sure that you have a spot for our new materials. New materials? What new materials? Okay, for those of you that are using your book, we're on M5, topic 1, which is probability. Okay, so in probability, we have new vocabulary. What is the probability of rolling a combination? What are the chances of picking a certain card? Are these actions, are these results, are these outcomes independent or dependent? What are the given statements? And then when we do it over and over and over and over, they're called permutations. So the first thing we want to do is get this new cheat sheet, and it's a packet. But we're going to go over it so that you understand why you get this big packet with only 3 weeks of school left. And then everybody gets their own set of dice. All right? So go ahead and pause the video. Mr. Miller's going to give you all this packet cheat sheet. It's 8 pages. No, I think it's, what is it, 4 pages front and back? Something like that. And then everybody gets their own package of 5 dice because we want everybody to be able to play Yahtzee. And yes, you're going to have your own scorecard. So we'll see you in a minute. All right, welcome back. Let's go over a couple of items here. Okay, first of all, the cheat sheet. Okay, these are the things we're going to try to accomplish in the next 3 weeks. Okay, so there's obviously got to be some math involved. Okay, and some of these are fun problems. On the very first page, it's called the fundamental counting principle. All right, what is the fundamental counting principle? What are all the possible outcomes given these statements? All right, and we'll do that probably next Monday, Tuesday. Page 2. All right, page 2 is the actual formulas, the actual math needed to do these math problems. Now, just because the math looks weird doesn't mean it's impossible. Most of you already know the answer, just not in the formal way we write it mathematically. Okay? Page 3. Now, Mr. Miller actually has this on a board. Okay? When we roll 2 dice, simultaneous, just what are the possible outcomes? From 1-1, called snake eyes, to a 6-6, called boxcars. Okay? And then we use this to calculate things mathematically. For those of you that aren't used to seeing the dice, 1-1, 6-6. And then these are entry task exit slips. And we'll be doing those over the next 3 weeks. All right? Page 4. Now, most people have played cards, but not everybody. You're going to get your own deck of cards late next week. Okay? Not this week. This week is all about dice. But in another week, you get your own set of playing cards. You're not giving us the dice back. You're not giving us the cards back. All we ask is that you keep those items with you over the next 2 weeks. All right? 3 weeks, sorry. Again, entry task, exit slip. Page 5. We want you to actually play Yahtzee. Now, if you've never played Yahtzee, we're going to be doing that on the 2 Fridays. Okay, last Friday, was that B cohort? I'll lose track of cohorts. Okay, so last week's cohort did it on Friday. This week, the other cohort will play Yahtzee also, and we'll show you how if you've never done it. But you have your own Yahtzee cards. Okay, so there's 2 on this side and 2 on this side. We want you to play Yahtzee. And as you play, calculate the probability of the event happening. Okay, now, as we wrap up the school year, the third week, these are called dependent compound events. Okay? You reach in, you grab a cookie. What is the probability of grabbing chocolate chip? Once you grab the chocolate chip and you ate it, the next day you come back and you reach in to grab a different cookie, or another chocolate chip cookie. What is the probability? Okay, so this really has a lot of math to it, so we're going to wait until just before school ends to study these type of events, all right, and the probability. Page 8, this is how we wrap up the year, the donut box, okay? And National Donut Day is coming up, June 5th. When we reach in to grab the first donut, there's a probability. Some of them only have one, like this powdered sugar jelly-filled donut. If there's only one of the 12, it's 12 to 1, 1 over 12. But what happens on day 2 when we reach in and we're trying to grab one of these chocolate bars? What is the probability of grabbing a chocolate bar on day 2? Okay, and we'll work through that last week also, because these are dependent compound events. All right, so that's our cheat sheet. All right, now you've all got dice. You've all got cheat sheet. Let's get started. All right, some vocabulary. Okay, now I want everybody, pause the video, and read what's in black, the first paragraph and a half. Go. Okay, now maybe you've done a spinner before, okay? If you remember back in distance learning, I had the spinner with our names on it, right? And we would spin it and a person's name would come up. What's the probability? What are the chances? Okay, some vocabulary that we need to start with. Sample space. First of all, in math, there's always some formal vocabulary. An outcome. That's what we call the result of an experiment, okay? The sample space is the set of possible outcomes of the experiment. Cool. It's just a formal way of saying what could happen, okay? So let's use our die. You all got these dice. It's a 6-sided dice, 1 through 6. What's the sample space of one dice? 1 through 6. 1, 2, 3, 4, 5, 6. That's it. Keep it simple. A sample space is a set of all possible outcomes of an experiment. An event is the outcome or set of outcomes in a sample space. So, I roll the dice and I get a 1. That's the event. 1. Okay, keep it simple. All right. Now comes the math piece. Remember, all math is the study of the real world, and we put numbers to it. So, the probability, here's the math piece of an event, is the ratio of the number of desired outcomes to the total number of possible outcomes. Okay? Well, think about it. I get a 2. That is the desired outcome. What is the total possible outcomes? There's 6. There's only one number 2 on here. So, the number of possible outcomes, 1 of these over 6 of them. Okay? So now let's work through this vocabulary with this spinner problem. Okay? A board game includes the spinner shown that the players must use to advance a game piece around the board. Cool. What is the sample space if a player spins the spinner? What are the possible outcomes? Just list them. I got a 1, I got a 2, I got a 3, I got a 4. I'm going to label them. 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. And it was even. That's not what we're looking at right now. All we're looking at is the possible choices. 1, 2, 3, 4. The sample space. And if you wanted to be formal, you could use set notation, the little fences, the little brackets. Okay, but the answer is 1, 2, 3, 4. That's it. That's the only things that can come out. That is our sample space, the list of possible outcomes. Done. Easy peasy. What is the probability of spinning the number 3? And we write that, the probability of getting a 3. So everybody, probability of getting a 3 equals, now, here's the math piece, the total number of total outcomes. Okay, how many total items on the spinner? Draw it in half here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's it. How many 3s are there? Number of 3s. Okay, how many 3s? Actually, let's just use yellow here. 1, 2, 3, 3. There was 3 of everything, wasn't there? Okay, so 3. 3. The answer is 3 of 12. Okay, now if you have to, don't forget we want to simplify fractions. And as we wrap up the year, let's start pushing ourselves a little bit. 3/12 equals math, convert to a fraction, enter, 1/4. 3 times 1, 3 times 4. 3 divided by 3 is 1, leaving us with 1 chance out of every 4. Okay? All right. Now, what is the probability of spinning a number greater than 1? Okay, pause the video. Everybody go. Do it. All right, welcome back. Greater than 1? Well, let's just subtract the 1s. 1, 2, 3. 12 minus the 3 1s equals 9. So, the probability greater than 1 equals 9 over the 12. 3 times 3, 3 times 4. Use your calculator if you need to. Ding, ding. 3 of 4. All right. So, you can see this video is 13 minutes already. I'm going to stop here, and then I'm going to go into our solo activity practice, what we're actually going to learn this week about probability. All right? So, welcome to class, welcome to June, welcome to probability. We've all got dice, we all have a cheat sheet, and we have our notes. See you soon.